This video is about Electronics Engineering Lab Assignment 1, which is Age Bridge Motor Direction and Speed Control. So the main objectives of this assignment were to understand the concept of age bridge circuit and its working principle, to design and build an age bridge circuit using a simulation software, and to control the direction of the DC motor using an age bridge circuit, and to control the speed of the DC motor using PWM signals. These were the marks distribution, and there were rubrics which included introduction, literature review, methodology, circuit diagram results, discussion, conclusion, writing and organization, referencing and citations. So all these have collective 100 marks. It was a group task, so I will explain the report and my other group members will explain the circuit simulations. So this is the report. Here we have table of contents, all the things present in the lab reports are mentioned here. After that we have list of figures because in this report we used a lot of figures, so list of figures and then list of tables. The objectives are the same as mentioned in the assignment, and then we have a introduction. So age bridge circuits are used in many applications where we have to control the direction of motor. So we controlled the direction of motor using age bridge circuit, and the speed of the motor was controlled using 555 timer IC, which was in a stable mode. This is the literature review about the circuit. Now to control the speed, we need to control the duty cycle using 555 timer IC, and for that we have formulas which were taken from uh, circuitdigest.com. These are the formulas. So if I explain you the circuit, so here is the circuit. Now we have potentiometers, two potentiometers. It's one end is connected over here and the other end is connected over here. We can move this by this plus, minus and plus symbols. So it's like a variable resistor, and it's also like a variable resistor. So R1 and R2 in this 555 timer IC are variable, and C1 and C2 were kept fixed. So we can change the duty cycle by varying the resistance. So for the high time we have this formula, and for the low time we have this formula. So if we increase R1, so we will have more high time, and if we decrease R2 we will have low time, so the duty cycle overall will be increased. We can also change high time and low time using capacitors, but we kept that constant. Here's the methodology. So this is the basic working of age bridge principle. If we have like four switches and the motor in between them, and if switch 1 and switch 4 are on and the current is in this direction, so the current will flow like this and motor will rotate in clockwise direction. And if switch 2 and switch 3 are closed, which mean they are on, so it means that the current will flow in this direction and the motor will rotate in the anti-clockwise direction. And this is the configuration which will burn the bridge. Now this was the circuit we created. These diodes and transistors are used as a switches to control the direction of a motor, and these 555 timer ICs are used to vary the duty cycle which will control the speed of the motor. So these were the results when we use logic states here to provide voltage to the circuit. So if input 1 and input 1 was on and input 2 was off, and pulse width modulations were high, so motor turned in the clockwise direction. If it was the other way around, so the motor turned in the anti-clockwise direction. If both were on and or both were off, so the motor stopped rotating. Here are some screenshots of the simulation which are explaining this table, which is if the both switches are on, the motor is stopped, which is 0.00 volt and it's not moving. And when both inputs are off, the motor is also not moving. Now, when one input is on and the other is off, the motor rotated in the clockwise direction. Here we can see it's a 0.63 volt. And here if you see the resistances are 10k and 1k. And in this figure we can see the this timer IC is working, and the motor is rotating in anti clockwise direction, and it's having a potential of minus 3.5 volts, and the resistances are 100k and 500k. 100k and 50 kilo ohms. So since resistances are greater here, so we have a greater potential over here, and the resistances were small here, so we have a smaller potential. So we can control the speed of the motor using by varying the resistances using potentiometer in real-time simulations, and we can directly increase them to see the results. So both the simulations were run for almost 1 minute, and in 1 minute this was minus 3.5 volt and this was plus 0.63 volt. So we can see that the speed of the motor can be controlled using 555 timer ICs. Here is the discussion based on these two figures. The challenge was that the simulations were taking a lot of CPU load and were not giving real-time simulations, so we needed to change the priority under the task manager for the Proteus software, and these were the conclusions by the group members which explained all the things. Now my other group members will explain the simulations and the circuit. And last but not the least, we had references, all those which were used in the report. For example, in the literature review section, we had few references from papers. So we also use in-text citation, which were present on the same page where we have used the references. And on at last, all the references were arranged alphabetically, and they were mentioned there.
Assalamu alaikum. Today I am going to explain the H bridge circuit. In this circuit, we are going to change the direction of motor, and also we are going to control the speed of the motor using and using timers. These timers will control the voltage in the whole circuit. So when the voltage is high, the motor speed will be high, but and when the voltage is low, the motor speed will be low. So initially, when we can make one input 1 and other input 0, then when the above input is 1, then q1 and q3 will be transistors will be activated, and the circuit will be such that the motor will spin in one direction, and the voltage across it is developed, which will determine its speed. And in this way the motor will turn, and if we want to reverse the direction, we will just change the inputs. Let's see, what if we make both zeros? What will happen? When both are zeros, the motor will tend to stop, but when one input is 0 and other input is 1, then motor will spin in different direction. So right now we can see that q2 and q4 are on, so motor will spin in different direction because the direction of current flowing through the motor is reversed. uh, and you can also see the voltage which is being changed by the timer IC. So this is H bridge.
Now we will see how we can control the speed of the DC motor using 555 timer ICs. Here we have two resistances in the circuit of 555 timer ICs, which will help us in controlling the duty cycle and high time and low time of the input provided by the 555 timer IC. Here we can see the R1 is 10 kilo ohms and R2 is 1 kilo ohms, and if we turn on the input 1, we can see the motor is rotating in a clockwise direction and the potential difference across the motor is increasing at a normal speed. Now if we change the resistances R1 and R2, we change R1 to 100 kilo ohms and R2 to 5 kilo ohms, so we can control the speed. We will have to look at the formulas for the high time and low time. By increasing R1, we can increase the high time of the duty cycle, and by decreasing R2, we can decrease the low time of the duty cycle. Since here R1 is very greater than R2, so the speed of the motor will eventually increase once we run the simulation. Now we can notice here that the potential difference across the motor is increasing at a very high speed, so this way we can control the speed of motor using P555 timer ICs or PWM signals.